Alright, you guys, so armed with our idea of multiplicity, we're going to revisit the idea that I playfully call curve fitting. So we're going to find a polynomial function that fits the information that's given, whether it's verbally given or whether it's given as a graph. Fit a polynomial that fits the situation that's given. And so when I look at this graph, what I notice is that there happens to be an x-intercept at -2, 0, and another one at 3, 0. And when I take a look at this one, it's not behaving like a line, so I know its multiplicity is not 1, but it looks like the multiplicity is at least equal to 3. Some might argue that it's 5, right? Because we know that that also gets a little bit flat, but we're just trying to find some polynomial that fits it. So why don't we just assume that it's going through like a cubic, right? If we just looked at that part of the graph, that almost looks like x cubed to me. All right, so that piece where the x-intercept is, the multiplicity is 3. And then at 3, it looks to me like the multiplicity is at least 2, right? Because it's touching the graph, and if we just looked at that part of the graph, that almost looks like a parabola to me, right? So it's behaving parabolic, or at least degree 2. Some people might say degree 4, but it doesn't seem to be real flat in that area, so I think degree 2. Right? So those are the only x-intercepts that I see. So that also means that if -2 is a 0, right, that means that x minus -2 is a factor. So x plus 2 is a factor, and that also means that x minus 3 is a factor. And so my polynomial at this stage is sum a, x plus 2, remember the multiplicity, to the third power, and then x minus 3 to the second power. And so just matching the multiplicities and the zeros, I have a factor raised to the third and I have another factor raised to the square power. Let me pause here for a moment because we'll eventually find a, but if we were to expand this out, notice that this would be a degree 3, this would be a degree 2, so overall we have a degree 5 polynomial, and that fits all the theory that we've talked about, right? Because concavity, it's concave down once, concave up twice, concave down 3 times, and then it's concave back up again 4 times. So there's basically technically 4 turning points or 4 concavity changes, and so the degree has to be 1 more than that, so degree 5. So my theory is matching up. What we can also predict is, since this is on its way up generally, I know that my leading coefficient, I'm expecting it to be a positive value. So you can see our theory starting to come into play as we try to curve for that. So how do I find that a? Well, why don't we look at another data point, right? It looks like this has a y-intercept at 0, 2. So if I plugged in 0 here, I get a 0 plus 2 cubed, 0 minus 3 squared, and that's supposed to give us an output of 2. So now we have an equation to solve. This is a times 8, a times 9, so 72 times a is 2. Divide both sides by 72 and do a reduction. I think we get 1 over 36. So what function is that a picture of? Our p of x is 1 over 36, x plus 2 cubed, x minus 3 squared. And so there's the polynomial fit, and it seems to match everything else we said with regard to the degree and with regard to our leading coefficient being positive. Everything seems to be a spot-on match. Of course, if you wanted to be sure, put that in your graphic calculator and see that it matches that. If I have time, I'll go back to that, but at this moment we've got some more problems to do, and I don't want the video to get too long. But that's also another way to kind of check to see what we did. Get technology. Your technology should match your algebra. All right, so that's that problem. The next one's a little bit more wordy, right? We're asked to find one polynomial that fits all of the following conditions. It has a 0 at -3 with multiplicity of 2. So how about we just stop there, right? So if it has a 0 at -3, that means it has a factor of x plus 3. And not only does it have that factor, but since it's multiplicity 2, we know that that factor is going to be squared. All right, so we've got that. The other thing it says is it has a 0 at 0. Okay, so that just means that x minus 0 is a factor, so that means x is a factor, right? And a 0 at 3 with multiplicity 4. So this means that x minus 3 is a factor, and that factor is risen to the 4th power. So putting this all together, my polynomial is sum A. How about I write that x out there first? X plus 3 squared, x minus 3 to the 4th. So that is what I know about this polynomial for what's given. Of course, I would have to be given more information to know what that A is, because there isn't really anything else given. We just know the zeros. There's 3 of them, and each one of their multiplicities. So this is about the best I can do. So maybe, you know, since we're just trying to find one, how about we just give it this one? This is the easiest one, where A is just equal to 1. All right, and we've got that covered. So there you go. You can make it 2, you can make it a half, you can make it 1 over 36. I'm just asking you to find one. All right, and I didn't give you enough information to find anything else, but there's our curve fit at the moment. So hopefully you see that theory coming into play as 0 causes a linear factor. All right, and we're just using that over and over again, combined with the idea of multiplicity. So one more, again, find one polynomial that fits all the following conditions. The first one is the number 2 is a 0 with multiplicity 3. So that tells me that my p of x has x minus 2 as a factor, and it's raised to the 3rd power because its multiplicity is 3. All right. The next thing is a polynomial has a root at -1. Uh-oh. We haven't heard that. All right. So what the heck is a root? Well, that is old-fashioned. Root is what we used to call zeros back in my day, right? I'll make myself feel really, really old. So be aware of that. You might read a book, or you might go to the internet doing a search, finding somebody who can explain this better or whatever, and you might actually see the word root. Root is just another name for 0. So a polynomial has a 0 at -1, and it behaves like a quadratic. Well, a quadratic is degree 2, so I'm basically telling you it has a multiplicity of 2. So my factor is x plus 1, right? And it's going to be squared because it's behaving like a quadratic. This will be touching the graph at 1 like that. The polynomial has an x-intercept at 4, 0. Well, if we have an x-intercept at 4, 0, that means x equals 4 is a 0. It doesn't tell me anything about the multiplicity, so how about I just make it simple and just make it x minus 4. If you wanted to be more complicated, make it, I'm just asking for 1, right? But you know, you can play around with the multiplicity of it. But I for sure told the multiplicity of my 0 at 2. I gave some information about the multiplicity at -1. And then we just were told we have an x-intercept at 4, 0, but it doesn't tell us the behavior. So I'll just assume it's a line. And then last but not least, they're telling us that f of 0 is equal to 8. Well, that's good to know because that's enough information to find out that lead coefficient. All right, so is it positive or is it negative? We'll find out. And so putting in 0 into the function, what we get is a 0 minus 2 cubed, 0 plus 1 squared, and 0 minus 4. So, and this is all supposed to equal 8. Well, -2 to the 3rd power is a -8. 1 squared is 1. And we have -4. This is all times a, and it's equal to 8. So a negative times a negative is a positive. So 32a is equal to 8. Divide both sides by 32, and we get a is equal to 1/4. So what polynomial fits this data? P of x equals 1/4, x minus 2 cubed, x plus 1 squared, and x minus 4. Now, of course, if you messed around with this multiplicity here, right, that's going to also have an impact on your A. So there's more than one answer here. I was just asking for one that had all those conditions, but there's actually several, depending on how you want to play around with your multiplicity. But hopefully, again, that continues to drive the theory about zeros, roots, x-intercepts, factors, multiplicity, and then putting it all together to find a polynomial that fits given conditions. All right, so we're going to transition now. We've been doing a lot of curve fitting. We're now going to do some graphing. All right, but I'll do that in a new video coming soon.